Good morning, live from the Brenna Bunker here in the quarantined Southeast United States. It is 8th grade science. All right. So day 2 of estuaries. All right, so we're trying this time. We'll see how this video goes. If this is an acceptable format, we may keep doing this. Here's my notes for today. So 8.E.1.2 estuaries day 2. I can recognize the importance of estuaries as marine ecosystems. Last time we talked about the definition of estuary and how they're formed. Salt content determines the boundary from 0.5 to 30 parts per thousand. So now today we're talking about the different ways of dividing up the pieces of an estuary. Specifically, so for this first part right here, we got this graphic right here. It kind of gives you the, here comes the river over here from this side. We got the ocean over here from this side. And you've got the upper, the middle, and the lower parts of the estuary. Now the upper part, you notice right here, it says fresh water. So there's no salt yet. The only tidal influence is reversing currents. So reversing currents means as the tide moves in, it pushes the water here, from here through here. And as it pushes this water up this way, this current, because normally water flows downriver, stops flowing and may actually reverse flow for a little bit as the tide hits its highest point. And so that's what that is. So, but that's what they call the upper estuaries, are those pieces of the river where the tide forces a reversal of flow. So that's what they call the upper estuary. The middle estuary is where we call where the actual estuary, because where the salt level is that 0.5 to 30 parts per thousand. Fresh and saltwater mixing zones. That's going to be what we call the actual estuary based on the brackish water definition. And this is lower or marine estuary. Remember, marine is the word for oceanic and saltwater. Ocean dominance, mainly saltwater. So when it says mainly saltwater, they're referring to saline, which is obviously 30.01 parts per thousand and up of salt. So you have marine. Just remember over here on this side you have riverine, which would be the characteristics of a river. So in the middle and lower estuary shores are divided into zones as well. So now we have the zones of the actual estuary. Now here we have the zones of what the shore of an estuary looks like. So middle and lower estuary zones, the shores are divided into the supertidal zone up here, which is above the high tide line. This area is rarely submerged, only in the case of severe storm. The intertidal zone, this is the area that is covered between low tide and high tide. See right here, this is mean low water tide, zero tide, mean high water tide, mean meaning the average. And then the subtidal zone, the zone that stays covered in water. And different things live in these different sections. So along the edge of the estuary, the three main types of habitats that need the estuary environment to survive. These are habitats that occur, but are primarily land habitats that happen to form near the shore. So you have a salt marsh, which occurs in this middle area here. You have the low marsh, the high marsh, and your upper border, and then upland, which is again going into normal land formations. And here it brings in some of the animals and stuff that kind of live in those areas. And then your seagrasses, which are flowering plants that grow in marine environments. So your seagrasses down here are below the tide line, low tide line. These things are seagrasses that grow in the water. They're not something that kind of pokes up. They're not something that kind of gets wet and gets dry. Seagrasses are totally submerged type of plants. And then, the mangrove. You ever seen that? Typically it's a tropical system. You don't see mangroves up in the northern um, estuary situations. They're different. It is a tropical situation, but it is a very, very regularly occurring, between, North Carolina going south, down into Florida, down into Central and South America. You have mangroves in the mangrove swamps. Again, you see mangroves operate where the tide comes in, covers up the creek. You see that bleached out look. That's the roots of the mangroves that experience the tidal covering. And they get totally uncovered when the tide goes out to the point where there's mud flats. Now, with all the divisions and zones, one can see the estuaries are incredibly complex structures that encompass many environments and niches that play a role in the diversity of life that use them as homes. So from animals that use the estuary to spawn and then move on to organisms that spend their entire lives there, estuaries are spectacular showcases of the diversity of life. Pardon me. So one of the benefits we get from estuaries is their ability to act as environmental filters. The myriad plants and animals in the environment filter pollution out of the water. How does an animal clean pollution out of the water? You might ask. The clam is what we call a filter feeder. So watch the video on the clams. It's a short video. It's about a minute and a half. But it'll demonstrate really quickly, how clams can actually filter water. And this is but one example of an organism in an estuary environment acting as an environmental filter. Some salt marsh plants trap chemicals, pathogens carried by river waters and move them into soils where they're trapped and neutralized. So we want to talk a little bit about the other things that we get as a benefit from having estuaries. So what you guys, I want you to go back and read this document thoroughly. You need to print it out for yourself or copy down these notes into your notes, and then from there you'll go on to look at the quizzes and some questions for your do now for today. So if you have any questions or anything, please let me know. 704-363-9034, direct phone number, text me. Otherwise, you can drop a question into the Google Classroom as well. Talk to you guys later. Bye.